All right, testing the sound. Sounds good. Okay. Website's updated. We're still a little before 11 here. I'm going to go get a coffee refill, I think, for myself before we get settled in. Excellent. hazelnut stuff is gone. How sad. How very, very sad. And put back in the wrong place. I may have grabbed it and taken it over to Rouge, but it was also getting low, so it might just be straight up gone. Oh, God. All right, y'all. I am here. Let's check sound again. Sounds good. Cool. get rid of that. Hopefully that'll help my performance a little bit. All right. So I am here. Happy Sunday. This is the Sunday chill stream, as I usually refer to it. Hi. All right. You're on my old camera, so you might have noticed a drop in quality. Nobody's watching these, and nobody's watching them consistently, so nobody's noticing a drop in quality. Anyway, top of each session, top of each stream, what do we say? We say abolish ICE. Abolish ICE, abolish ICE, abolish ICE. I have the tiniest little platform, and if nothing else, it feels wrong to have any amount of platform and not be ringing alarm bells about what's happening in our country. So that's what I'm doing here, but that's not what this stream is ultimately about. It's about helping you with math. So the things I need to do, I need to check for refresh my, there we go, my submission form where you can submit questions. If you go to the calculustutor.com/live, or if you just go to the calculustutor.com, you can, there's buttons and you can follow links to submit questions. You can also just email me directly, ryan@thecalculustutor.com. Really, really easy. I will probably go through how to submit questions again at some point, but I've gone through it a number of times in previous streams, so you can go back and look at those VODs if you're not sure how to submit a question. But honestly, if you're not sure how to submit a question, just email it to me, ryan@thecalculustutor.com. Simple as that. If you go to thecalculustutor.com/live, scroll down a little bit, there's guidance for what to include with your question, but you can also just send me your question. And if there's not enough information there for me, or if I'd like a little bit more context or something, I can just email you back, right? No responses in here. I didn't see anything in my email inbox, but we'll refresh just in case. Oh, inbox. Oh my gosh. Just assumed I was in my inbox and I wasn't. Okay, there's that. Take a second to load. There's that. Nothing in spam. Okay, there's no questions right now. So to give myself something to engage with these streams when there's no questions, like I could come up with like math problems to go over, and sometimes I like take math problems I've worked on with my one-on-one students and use those during the stream as just an example, as like a problem to go through. But like I've already answered that question for the student. Sometimes my one-on-one students submit questions to me in between sessions, and I'll go through them on stream and then send them the response back. But more often than not, what I'm finding with these streams is there's no questions because I haven't figured out a good way to advertise these yet. And so really nobody's taking advantage of them, which is fine for right now. I do plan to hang flyers at the university, at the community college. I think college students might take advantage of this. Anyway, all that to say, I want to keep doing these on a regular basis, just for the consistency of it. I think I might reduce down. Right now, my schedule has reduced all the way down to twice a week. Sundays at 11 a.m. Pacific Daylight Time right now. And Wednesday at 3 p.m. again, Pacific Daylight Time. And then I want to allow myself to just do impromptu or unscheduled streams, kind of whenever I want, right? And that's more likely to it's more likely to happen if I have questions waiting for me, like, I do my stream on Sunday, somebody submits a question on Monday. If I'm not streaming until Wednesday, that might be too late. That might not be uh, fast enough to be useful and helpful to that person that submitted that question, right? And so I would probably, depending on when the problem comes in, I might do a stream on Monday to answer it. And so it'd be a short stream, just a stream to answer that one question. But I could just do that whenever is convenient for me. Or maybe if it comes in late on Monday, maybe I do it Tuesday, right? Regardless. So 2 scheduled streams that I will hit on a regular basis. And until I'm building up a volume of questions waiting for me, and if I'm answering questions, that come in on Monday, if I'm answering those on Monday or Tuesday, I still won't have anything for my Wednesday stream, right? So I need something to do during these streams. I need something consistent, basically a bit of a project, right? And granted, answering questions is the primary purpose of this. Is that will always take precedence. But I still want to sit down for like at least an hour on the Sundays and Wednesdays on the scheduled times and do something math related. I've been trying to figure out what that was. I thought, and I'm still considering maybe going through the OpenStax calculus textbook or books, and just doing all of the problems. That could be fine. Though I know, especially the early chapters are so boring, but I don't know, the completionist in me is like, well, you can't skip those. If you're going to do it, you have to start from the beginning and you have to just do it all the way through, which is just an arbitrary, dumb standard that I'm holding myself to. That's not like a real standard, but there it is regardless. And so part of me is like, I don't even know how to publicly, I guess, answer some of those early questions because they're just so straightforward. But I guess that's what you do. You just show that they're straightforward. And then let people ask questions, I guess. It's there to drive people to have questions. Anyway, so I've thought about doing that, and that's still something I might potentially do. I think I would enjoy having solutions to literally, well, I don't think I was doing all of the problems in the OpenStax textbook. I think the even problems or the odd problems or something have answers provided, not solutions, but answers at least. So I was going to work out full solutions at least to all of the other ones, right? So either the odds or the evens, whichever ones don't already have answers. Anyway, I would myself enjoy just having done all of that and having that as something I've produced as a work, right? So, and a work just publicly available on the internet. So that is something that's on the horizon. Instead, so what I've come up with that's gotten me back into the streams, that has me starting to feel a little excited to do them rather than annoyed or dready. Not because I don't want to do them, but just because I know I don't have anything particular to work on. And again, I've said before, I don't really like busy work, so just finding any old thing to do just has not felt good to me. So all of that to say, and it's in the stream title and stuff, I wanted to start working through Project Euler. So let me show you what Project Euler is. Actually, let's do it this way. I think that's fine. Sorry, y'all. I'm running into issues here. Uh-huh. Do I have to? Okay, hold on a second. Okay, then I close this. Huh. Okay. Fascinating. There we go. Sorry, I realized I should probably like browse in like an incognito or tab, but the incognito tab displays my bookmarks bar even if I tell it not to. It's like a bug or something, I guess. Um, so I need a guest tab. But anyway, just I don't know. You guys don't need to be distracted by the various folders and things in my bookmarks bar. Um, right. But now that I have that, what I wanted to do was share my screen. Uh, Excellent. Okay. So I wanted to show you guys, and I wanted to start working on Project Euler. So projecteuler.net, very old school website. It's been around for a really long time. In fact, does it say anything about? No, this is just okay. Yeah. Okay. Sorry. Got distracted by their copyright information and like how to like cite stuff because I realized I'm sharing this, so I should actually probably do whatever I need to. Maybe I should start putting an attribution in the description of my videos or my streams. Anyway, okay, sorry. What is Project Euler? You can see it. Let's zoom in a little bit and make it a little bit easier for you guys all to read and see. Um, so is a series of challenging mathematical slash computer programming problems that will require more than just mathematical insights to solve. Although mathematics will help you arrive at elegant and efficient methods, the use of a computer and programming skills will be required to solve most problems. Um, Motivation for starting Project Euler and its continuation is to provide a platform for the inquiring mind to delve into unfamiliar areas and learn new concepts in a fun and recreational context. That is fun and recreational context. I love that. Um, oh, actually, hold on a sec, y'all. Give me one moment. I'm back, but let's check volume here.
Okay, says I'm live. All I'm trying to do is check the volume. Sometimes when I mute it and then unmute it, it doesn't unmute. Test, test. Okay, seems a little quiet. Turn on the mic a little bit. I'll turn up my volume a little bit. My volume was down a little bit low. So test, 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 test. This is probably my regular volume. Okay, we'll call it good. Sorry about that, y'all. Yeah, my partner was leaving, and we just needed to check in really quick. Yeah, and I needed to catch them before they actually left the house. So I did, and now I'm back, and we're talking Euler project. So Euler Project Euler is it's computational mathematics problems. What I studied in undergrad was applied mathematics, which was a lot of computational math because that's how math is applied in the real world, right? There's certainly mathematicians who are doing purely theoretical work, right? Who are pushing the advances of the concept of the concept of the concept of a number. And they're doing purely theoretical work, and they don't do any computational work. That is a minority of the people who do math work like professionally. The majority of people who do math work in their day-to-day lives are doing computational math work. They are having a computer figure out the end result for them, right? And so a big part of learning math, and unfortunately a part of math we're not teaching, and I've been advocating for this not even in my entire teaching career, but basically since I was in high school myself, right? We're not teaching math students how to use the tools of the trade. We're teaching them pure math concepts. We're teaching them how to do math by hand, which is necessary. You need to learn those skills. There is a place for it. However, we're not teaching hard. We're basically teaching to regular math students who are in their required math courses, right? Their 8th grade maths, their algebra, geostats, algebra 2s, trig, pre-calcs, calculus, those like that regular sequence, right? I'm not talking about students taking elective courses or specifically taking programming courses. I'm talking about in the course of a regular math curriculum, learning how to use a TI-84, learning how to use, or not even just a TI-84. Sure, a TI-84, a graphic calculator, but learning how to use a TI-30X effectively, learning how to use the variables in it, formally learning, as in it's part of the curriculum, not a teacher snuck it in, not, oh, we hope they learn it over the course of their algebra class. They'll have access to the calculators. We'll let them use them. We're never going to teach them formally how to use. We're not going to have formal instruction on it. We're not going to have assignments about how to use them. We're not going to have tasks specifically meant to teach them how to use it. We're just going to hope they figure it out. With a basic scientific calculator, much less a graphing calculator. And those are super outdated. They shouldn't even be learning how to use those. What they need to be learning how to use is Desmos. They need to be learning how to write Python script. Python is probably there are two languages. Python and R are probably the two most used languages for people who do mathematics in the real world to solve real problems. I'm not even professionally, but it doesn't have anything to do with getting paid. It's using mathematics to solve problems in the real world. Those people are almost certainly going to use either Python or a language called R, just the letter R. Anyway, so with that in mind, I'm very familiar with Python. I use Python for my own personal projects. It's the first language I go to. And then if it makes more sense to do so, I also use like Dart to build mobile apps. Right, use the right tool for the right job. But Python is super what's the word for it? It's good for it's a multi-tool, right? It's a tool that's good for a lot of jobs. And then R is primarily used for like data sciences. But you can script in it. But I do not like it. Partially because I haven't used it a ton. And so part of the motivation for me wanting to do this is I'm going to work a lot in Python, but I also want to challenge myself to do some of this in R. Okay, so what are we looking at with Project Euler? So that's what it is. I found math homework for myself to do, but it's math homework I'm interested in doing rather than say just like the arbitrary decision to do all of the OpenStax calculus problems, which I do see a use for. It is something that is interesting to me. This is more interesting to me right now. So yeah, these are problems that are constructed in such a way that it would be unfeasible, potentially impossible to solve these problems and get to the correct solution by hand, because you'd have to do so many repeated calculations, thousands and thousands of repeated calculations, or things like that. Or you just have to deal with huge arrays or huge vectors or huge matrices, things like that, things that would be so impractical to work out by hand. And so, yes, but what that means is we'll have to figure out the underlying mathematics of it, right? So that'll be handwork. That'll be work I do in the notes. Just trying to wrap our heads around the mathematics at play. And then we'll sort of write some pseudocode. And then we will go and we'll write some Python code and potentially some R code. I kind of want to challenge myself to do all of the problems in the R language as well, but I don't think I'm going to do like the problem in Python and then immediately do the same problem in R. I think that would start to feel tedious to me. I think what I'll do is I'll do like several of the problems in Python, then I'll go back and work through maybe all of those same problems in R, just to give myself something to practice on and to put some, to have some workout, some R language work out there. Yeah, so this is Do they say how many problems they have right now? I think it's like 900 or something. And there's a tracker. So I mean, anybody watching who's at all like interested in computer programming and is like looked at computer programming has probably heard of the website Leak Code. Project Euler is basically leak code, but not aimed at like programmer bro culture and like getting a job. This is just, again, it's recreational and it's more math. It's more specifically focused on math things, whereas leak code is focused on like the essentials and the challenges of sort of algorithm design, which is sort of a little bit more abstract and also slightly different, but very related. Anyway, so here, if we go to the archives though, oh, I'm not sharing my screen. Oh my gosh. When I reconnected, I needed to reshare my screen. That's okay. I was talking and I was reading a little bit of stuff, but if I'm so, okay, I was there. We're now in the archives. The 1 to 984. They're not of 1,000 questions here. And you can, I think, can you just go in and see any of the, yeah, you totally can. Okay, so here's just an example problem, right? Where I want to work through these in order. We're going to talk about that, what the goals of the project are. Oh, speaking of which, here, let me get my. I'm so silly. I didn't open my Miro board for the stream notes because I knew I was going to be talking about this other stuff for a minute first. But I want to get that open and loading. There we go. Okay, so back to this. All right, so here's an example. This is problem number 10. So they all have a title. They're usually fairly short. Some of them are a fair bit longer because there's a lot of like detail to the problem they need to communicate. But they say the sum of the primes below 10 is 2 plus 3 plus 5 plus 7, which is 17. So it's an example of a thing you could do. You could sum the primes below a certain number, and so they say below 10. But what they want you to do is find the sum of all the primes below 2 million, right? And so this is putting it on this scale right here means that you could do this problem by hand. But that means identifying primes by hand, primes that are getting huge, right? 6, 7-digit primes. Even doing 5 and 4-digit primes, 3-digit primes, verification is going to be tough by hand. You have to verify all of those by hand. Then you have to, once you've verified all the primes up to 2 million, then you have to add them together correctly. And that's still going to be hundreds of numbers, thousands of numbers. I don't know how many primes there are below 2 million. There's got to be at least a few hundred though. So anyway, that's the problem. So I want to work through these, but here's what I want to do. I want to, and this is actually the continuation or the restarting, the reboot of an old project of mine that I was doing for a while, which was working through all these Project Euler problems in order. You can skip around. You don't have to answer one question to go on to the next, but why not do them in order? I'm not, if we could browse through at some point and do some out of order if there's ones that look particularly interesting or something, but I'm going to do them in order for a little while. I kind of would like to do like the first 100 Euler problems, right? Like just having that done, I think would be an accomplishment and kind of neat. And then from there, maybe skip around. But anyway, regardless, I don't want to just find the sum of all primes below 2 million. I want to write. So once we do that, I then want to generalize the problem and so actually it's not even after we do this. I don't want to write a program that will find all the primes below 2 million. I want to write a program that will find all the primes below a given number. So all we have to do, so we could put in 2 million as the input for this one and get the answer, and then we can check our answer. We'll talk about how we do that. But I want to also be able to input without changing any other code other than the input, put 3 million or put 586, something like that. Just put any arbitrary number in there and have it give me the right answer. So it'll be able to answer this very specific question, but it would also be able to answer any question just like this, right? And so that's what I would like to do, is have generalized solutions. And so what that's going to require us to do is, so if we were to, well, here, let's, I think we have the time. There is, let me show you this. So I have not, I'm pretty sure I haven't registered yet. I have an old account, but I'm going to start a new one for the calculus tutor stuff. Sorry, let me see if I made this login already. Oh, I did make it. Okay. So let me or I don't think I did. No. I know I didn't, because what I wanted to do was, there is a problem 0. So this is kind of fun. This is just a super straightforward, a very flavorful, a very fitting way for them to check for bots and prevent bot signups. There is a problem 0 described here, and in order to even register, to even get to the registration screen to set up an account, you have to first answer a question. The first problem is very, very straightforward, but it still takes a little bit of thought. It's not trivial. It's not just like answer this multiplication of 2 huge numbers, which they could do, and that would be fine. So, all right. So here is problem 0. A number is a perfect square, or a square number, if it is the square of a positive integer. For example, 25 is a square number because 5 squared, which is 5 times 5, equals 25, right? So 25 is a square number. Oh, what is that? Oh, interesting. Okay. Sorry. 25 is a square number. Okay, very good. The first 5 square numbers, okay, so if you do 1 squared, you get 1, 2 squared, you get 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, okay? And the sum of the odd squares, so we're skipping 4 and 16, so 1 plus 9 is 10, plus 25 is 35, right? So among the first 498,000 square numbers, what is the sum of those, of the odd squares, right? So not only do we need to find, or do we, the first 498,000 square numbers, right? So that means going from 1, 2, 3, 4, 5, all the way to the number 498,000. Just taking those numbers alone, squaring all of them, then taking the ones that are odd numbers and adding those all together. So since half the numbers are odd, we won't be adding together 498,000 numbers. We'll be adding together 249,000 numbers, right? But is that something you want to do by hand? That would take days. That would be a project you would have sitting on a table, and you would sit down for like an hour a day and add numbers together, and then get to a stopping point and come back again, right? Which means it'd be super easy to make errors. So you'd probably want to do it twice to check your answer. And then if you get 2 different answers, you need to do it a 3rd time, right? So like just, not anything you'd probably want to do by hand. Not anything a human maybe has ever done by hand, honestly. Back before computers and things like that, like when the only way people could do difficult mathematics was to do it by hand, people certainly did. People certainly did demonstrated amazing mathematical feats of manual calculation, right? Um, Manual computation. Um, but I don't know if anybody in the history of humanity has done something like add 249,000 different numbers together. Um, I mean, it's not impossible. And like I said, you could split it up amongst a bunch of people. You could one person could come back to it over the course of mul- multiple days um, until it was done. Anyway, all that to say, we're not going to do it by hand because we have computers. um, and computers are how mathematics is done today in modern day. So here's what I'm sort of figuring a little bit of this out as we go. And part of the reason I'm using my old camera is because in order to share my screen effectively and work effectively, um, I need to be on. I need to be streaming from my main computer, and lately I've been streaming from my Surface because I can use the better camera on it. Anyway, doesn't matter. Um, so here's what we're gonna do. So we will figure this out and we will answer whatever total we get. We will answer it here. We'll enter this captcha. I think it's really funny that they have a captcha, but I guess a bot could come in here and just try numbers over and over again if there wasn't a captcha. So a bot could brute force it. But the captcha helps prevent that. But anyway, we'll enter that. We'll enter the captcha, and then if we're correct, it will take us to the registration screen where I either have already registered, and so we won't need to actually register because I've already done it, or I saved registration credentials for myself that I haven't actually entered yet. I have credentials. I don't know if they've actually been used. Anyway, so let's talk about how we want to do this. Here, I'm going to stop my share because I need to share my screen differently. Actually, let me. Okay, there's that. Okay. There we go. That should work. Let me share my screen again. And this time I'm going to share the entire screen because you're going to need to see how I do some of the stuff here. Nice. Okay. And we'll hide that. Okay, so I made my screen. There we go. So I narrowed things a little bit, just because the way I work my notes is vertically, right? So anyway, so here's what I'm thinking about doing. Here's how I'm thinking about doing this. I'm going to grab this problem. And I'm going to put it in the notes. What's happening? Oh, I can't edit. I'm so silly. Okay, hold on a sec. Let me. I'm figuring this out in real time, y'all. I apologize. Boom. Okay, here we go. I couldn't paste into it because I just went to it in the guest window. So silly. Okay. It's everything's loading. So give it one sec. Cool. All right, let's try that one more time. Share and entire screen. This one. Okay. Hey, how about that? Give me one. I'm checking on another thing here. I apologize. I've just had various things fail, right? So like that's why I always have to check the volume when I unmute is because I've had the mute just like cut the volume for the stream. Like I mute, unmute. It just doesn't reconnect the sound. I've had screen shares just black the screen. And I'm looking at my feed here, and it does show the screen share, but I can't remember if I've ever had it black the screen for viewers, but not for me. So I'm just checking just to be sure, making sure y'all can see what I see. Yep, you can. Okay, so screen share. I mean, this is a thing that actually having viewers and having a chat is nice for. Is you can just ask them, hey, can you see this? All right, though. Here we go. So now I can paste this because I'm actually viewing it with my editor permission. Oops, that's... There we go. Okay, so problem 0. So this is like our header. Right, shows that we're working on a... I think what I also want to do is link to it. This is the registration problem, though, so there's not really anything to link to necessarily, other than the registration page, but maybe I will for good measure. So now if I do that and I do Control K, no, that doesn't work in Miro. You have to instead go to link to, it's Alt Control K. Boom. And now check it out. This image isn't itself, but has right there a to the actual problem, and we'll just do that for all of them. Okay, so this is what we're working on now. How much time do we have? Oh, right. Yeah. Okay. Plenty. So let's see. And now I get to think about, and because I want to teach these as I work through them. I don't want to just sit here and work through them silently. I want to talk about what I'm doing. Right. So let's talk. Should we just make some initial notes? I suppose. Didn't actually have my Surface even on because I knew I was going to be doing the Euler project stuff, but I didn't think about typed notes. Does seem kind of nice. We can hand work through stuff when we need to. But for right now, but like notes and things. So yeah, let's just. And actually, I'll probably make some templates for myself and stuff too. For like notes and. Okay, but no, we don't want that. We just want like probably. No, 18's too small. 24. Still kind of small on your screen. 36. That seems better. Okay. So this is boom. Okay. Let's do this. And we can sort of talk about some initial ideas and things like that we might want to think about. I need to move this down so that the, oh my God. There we go. Is that, that's better. Okay. So we can just sort of talk about initial ideas and things that we know are true or things that we know are relevant. So we're squaring numbers. That's an easy thing for a computer to do, is square a number. I mean, you don't even have to, you could just multiply it against itself, right? We don't even have to actually square. We can just take any number we want and say, you know, call it x and say x times x, using multiplication. So that's pretty straightforward. So spring 2026. Sorry. There we go. So we know that's straightforward to do. We're not going to have to worry about that. The biggest thing is, so it's 498, the first 498,000 square numbers, but we know we don't care about the even ones. So we still know we're dealing with 249,000 individual numbers, but they are predictable. And we know how to get each of them. To get the first one, you just square 1. To get the second one, you square 3, right? So notice, okay, so this is a thing we can write down. Odd squares are the result of squaring odd numbers. Or another way to say that is even numbers never, actually, yeah, so what is that here? What I meant to say was that what that tells us is we can ignore all even numbers in our initial list. So our list, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 498,000. We actually don't need to worry about the 2 or the 4 or the 6. So we can go 1, 3, 5, right? So that means we're going to look like 1, 3, 5, 7, ... Right? So that's what our initial list is going to look like. Okay. And then what we can do and honestly, like I said, this first problem 0, this is just to sort of show you what we're dealing with here and why we would need to use a calculator of some variety, something we can program. Okay. Okay, so we know we're going to want some initial notes. We're also then going to want it's not giving me a distance for some reason. That's fine. Okay. I duplicated those because I do that. I want to turn this into a list. And I want to turn this into process steps. Okay, so what we're going to need to do is plan out the steps. This is basically pseudocode. So like we're going to write actual computer code when we write Python, but we need to design what we're going to build, right? When I was going through school, we talked about computer programming as software engineering, right? You're engineering a thing. You don't just, if you're building a bridge, you don't just go out and start building the bridge. There's all sorts of careful design work that happens ahead of time, right? Things checked and double checked, and you need to know what materials you need and where you're going to get them and how they're going to be delivered and where they're going to be stored, and so that they're accessible when you need them for each step of the project. And you're going to need to know who's doing what at each step of the project, like each individual person, what are they doing, right? So you have to plan you have to plan it all out. Same thing with software, and that's ultimately what we're doing. Is we're building a little tiny simple piece of software. We're building a little tiny app that this is all it does. And these are the building blocks of computer programming. If you're all interested in building apps or full big computer programs, including like games and stuff like that, these are the building blocks you need to get there. Not the math stuff necessarily, but the learning how to design an algorithm and then implement it, rather than designing it while you're implementing it, which I totally do all the time in personal projects, right? That was what vibe coding was before AI existed. It's where you would just sit down and code, not based on any existing design, and plan just based on your vibes and the direction that you felt like going. But yeah, I want to try to demonstrate best practices here, things like that. And so, we're going to have a design. And we might come back up here and flesh out our notes, add more to them, things like that. As we realize what we need as we're sort of planning out our steps here. But here's what we're going to do. We need to, and so we're going to plan out we're going to plan out for a for the generic version. I don't want to plan how to solve this specific problem, the 498,000 problem. I want to, from the beginning, plan how to solve this for any generic version, for any number they could put in here. You could put in 5 million here. It might take the computer a while to do it. And that's the other thing. Our goal here is not to write the most efficient program ever. It's not to write the fewest lines of code. It's not to write something that's the most memory or process or like compute intent or efficient. If we there will be places where we definitely need to like design for efficiency in order to solve the problem in any reasonable amount of time. But if our program takes 10 seconds to give us an answer, and theoretically you could write a program that could do it in 2 seconds, I'm not too worried about that. Right, I'm mostly interested in thinking through the mathematics of the problem and converting that to a script, a computational script that will do the computation for us. Now, granted, yeah, in real life, you might need to be thinking about efficiencies and things like that. So we will probably talk about it a little bit, but it's not going to be my focus with every single problem, right? So anyway, and especially when we're starting out, you can't start out with the intention that the first thing you design is the most efficient thing possible. You have to build a thing and then optimize it if you're interested in it, if you are interested in trying to optimize. So what we're gonna do is just come up with a process that we're pretty sure will work. And then from there we can optimize it. And sometimes that's, you design your thing, and then maybe we do build it in code, and then we go back to the design and change the design we optimize the design, and we go back and rebuild. There's lots of ways to do that. But yeah, for our purposes right now, we just need something that will get us there. But my focus is to do it for a generic version of the problem rather than this specific problem. So with that in mind, what we need an input, which is our initial our limit value. And so I'm just gonna say we have a limit. So we need to get or set get limit value as input. Okay, cool. It needs to be able to read in that limit value, which is the 498,000 or whatever other arbitrary number we want to put in. For this problem, we'll put in the 498,000. Though you might have noticed this note here, the numbers in the problem, it's just specifically this number. That will change occasionally. So before we do this, we have to refresh the page. And that's part of why I want to do this in a generic way, is this number is going to change before we submit our answer, probably. And so I want to be able to just very easily run this again for any number they might put here. Okay, so we want to get the limit value as input. That's our first step. Then, once we know that limit value, we want to make a list of all odd numbers up to limit. Up to and including limit if odd. There we go. So yeah, if it was 498,001 was our number, we would want to use that last one, because it's among the first of that many, which is inclusive. Actually, let's all numbers up to limit, and we'll just say inclusive. Okay. So we will then square each. Oh, actually, we'll say this. Here's how we'll say it. We'll say make a new list by squaring each number in the first list. Make a new list by squaring each number in the first list. Now, add together. Or here, we'll use math vocab here. Oh, this is behind my. I'm so sorry, y'all. I forget that my image is inset right there. Duh. I guess I could swap what side these things are on. That might be useful. Let's do that. Like, you go there. You go there. Okay. Perfect. And down at the bottom, but you can see it at least now. Okay. So we want to say sum, and we can say find sum of new list output sum. Okay, so it's a little 5-step program. And actually, this isn't as efficient as we could make it, but I didn't want to talk through any of those efficiencies until we started actually talking about code. Right? All right, so now what we want to look at is, so we've done, so most of the problems are going to be more involved in this. So there's going to be more math to talk about. There's going to be the steps. There's going to be more steps, and the steps are going to be sort of probably more fine-grained and potentially more complicated. Yeah, so this one is really just a demonstration, and I really like that there's a problem 0. The first few problems are pretty straightforward. They're not that bad. Okay. So now the question is, how are we going to write this code? So if you've never written any computer code, you've never written a script that was executed or anything like that, you probably don't know how it even works. How do you even write a computer program? It's honestly, a computer program is just a text file that's understood by another computer program to represent computer code. And so it reads it in a particular way and does particular things with the text inside of it. We're going to use Python. And so what I recommend for you, so there's also, find a tool you like if you want. I'm going to recommend this thing called Idle. So if you go to, don't go to this one. This is the documentation. There might be a link in here, but we're going to want to go here. So python.org is the website for the Python programming language. And then there's this download button, but what I want is idle. And that's what I was trying to find for you all. If we go, nope, it's just going to start downloading. I'm going to cancel that. Okay. Let's go here. When you install it, does it ask you if you want to install idle? Is that actually how that works? Hold on. Sorry, y'all. I know for sure this isn't how I. Oh, you know what I think is happening? Okay, I know what's happening. I'm on Linux right now, and when I go to this page, it knows I'm on Linux, and so it's giving me this. So if you're on Mac or Windows, right? So here's Windows. Use the install manager, right? And if you're on Mac, I assume they also have install manager. Yeah. There's a Mac OS installer. There you go. You don't want to use that, and that will give you an option to install something called idle, IDLE, all caps, because it's an integrated develop. What does idle even stand for? Does this tell us what idle stands for? Oh, Python's integrated development and learning environment. That's what the L stands for. So yeah. So it's the program that reads your code file and does something with it, right? That's what idle is. You need to install the Python language so your computer knows how to interpret Python, and then this program uses that knowledge to actually run your code. So anyway, so that's how you get there. So let's yeah. So you can just, if you just search, if and just based on your operating system, install the thing. It should ask you if you want idle, and you do. You want to install idle. So what I'm going to do now, I'm going to run idle using, what is this? Is idle using Python 3? Yeah, okay. If you should you should go ahead and install Python 3. That's the Python 2 is still kind of being supported. Like there's been some changes in Python 3, but it's like stable now and it's good. Okay, so this is what we have here. Let me dock us over here. And it's basically just a computer terminal, right? I can do something like 2 plus 3 and then hit enter, and it was 5. It's a calculator. But I can also do something like print hi there, and it just says hi there. Right, I can, ooh, this is nice. I can do print oops, like this, and I can do 2 plus 3 equals, and then right there I can do 2 plus 3. Is that gonna work? Haha, I can. So 2 plus 3. Notice I never wrote 5 in there. What I did is I put 2 plus 3 in these curly braces. Oh, that's the thing I'm gonna want to do. I want to make this text bigger for you all, huh? Yeah. So yeah, I'm showing this stuff off, but let me options, file, edit. Yeah, let's configure idle. There we go. Size. Oh yeah, size 9. Yeah, we're gonna need to go up to like 14, I'm sure. At least. Hey, that seems decent. That looks good on there. Okay, cool. We'll do this. Anyway, so yeah, 2 plus 3, and I hit enter, and it gave me 5. I did the command print, and I gave it what's called a string and told it what to print, and that's what it printed. And notice there's no quotes there, it just printed the string itself. This, I told it, you're going to print something. This F makes this what's called an F string, which means it will print exactly what you put in here, but you're also allowed to put it in curly braces and have it like actually do some logic in whatever's inside those curly braces, and it will replace that with whatever it computes. So notice it says 2 plus 3 equals, that's the stuff I actually typed in and told it to type. And then it replaced this entire set of curly brackets, curly braces, with what they're equal to, which is 5. Neat, right? Okay, cool. So this is the shell. This is interactive Python. It's executing as you write stuff. We could actually do our steps right in here. Most of the time, that's not what we're going to do. We're actually going to write a file and then have it execute that file all at once. But for our purposes here right now, especially since we're getting low on time, I'm gonna end the stream at 12:30. I have a one-on-one student at 1 o'clock. Oh, and this is a good reminder. I offer one-on-one tutoring on a sliding scale. My advertised rate is $50 per hour. That's essentially what I would need to survive if I had a minimal stable of students. So if I have a minimal amount of students actually paying me that, then I can afford for everybody else to pay whatever. Or if I have some extra students and they're all paying a little bit less. Anyway, none of that matters. I have a sliding scale. $50 is my max rate. $50 per hour is my max rate. I mean, I guess you could pay me more than that if you wanted to. Most sliding scales go down, but I guess it could slide up, right? Regardless, if you would like one-on-one tutoring, which I do over the computer, but it's through like a Zoom call. We're right there together. You have a private notes file that's all your own that you can access anytime. Yeah, and I do hour sessions. We can do an hour and a half or 2 hours, but most of the time an hour is plenty for most in terms of like what they're after that, their brain sort of needs a rest. Anyway, you can hire me or work with me one-on-one. Reach out. But yeah, so if we look at our steps here, oh, here, no, that's not how you clear it. How do you, restart shell. Can I clear it? Okay. Apparently I can't clear it, but I did restart it. So none of that stuff up there. It's as if none of that stuff happened. Can you clear? No, it doesn't like clear either. Okay. Oh, can I do... Okay. That's kind of annoying, but okay. Okay, so we can So getting this limit value as an input is going to be hard here. Basically, because none of this is self-contained. If we were to write it like an actual self-contained program, which we will do, and that's maybe what we'll do at the beginning of the next, or in the next stream. For right now, I want to show just as a demonstration of this, we right here live. And there is a way to do it so we can rerun the stuff with the same program, but I don't want to get too deep into the weeds since this is our first time out and we're just sort of learning, right? I just want to show you some of these basic things. So I think maybe on the next one, we'll actually write it as a script, as a self-contained file that does stuff more efficiently and can have a customizable input value. So, okay. What we want to do. So we want initial list, right? So this is just a variable. You can call variables anything. They can't have any spaces, and you can't start them with a number. So our initial list, and in like math class, you probably would have just called, we use one letter variables. You just call it X or Y or M or N or something like that. In programming, we use multi-letter variables so we can be very clear about what they mean. So our initial list, and so I'm going to use something from Python called range, which just, that's what it does, is it creates a list of numbers, but you can specify some stuff. You can specify, and look, it pops up, it tells us how to do it. So range, I can specify a start number, a stop number, and a step number. So our start number is going to be 1. We want to start at the number 1. We want to stop at the number 498,000. And we want our step to be 2. What step means, how does it get to the next number in the list, right? It's going to start at 1. And if we didn't specify that step, it would have just given us 1, 2, 3, 4, 5, all the way up to 498,000. But now, because we specified a step size of 2, it's going to give us 1. 2 to that, it's going to give us 3, and then 5, and then 7. It's going to give us just the odd numbers, right? So actually, maybe we call this odd list, right? So now if I hit enter, okay, notice it didn't display anything because I made a variable. So now if I say odd list, it just tells us what it is. It tells us it's a range. That's fantastic. Okay, it doesn't actually list all of them out. If I were to print it, what would happen? And again, it just still tells us what it is. Interesting. Okay, cool. So it's a list of numbers now. It doesn't want to display all of them. Good, because like we talked about before, that'd be 249,000 numbers. That would fill up the screen and take forever to display. So this is excellent. So we have our odd list. So that's our, and our limit is sort of in here. We want to make a new list by squaring each number in the first list. Okay, actually, this may not be as straightforward to do as I was kind of thinking, but I think we can say square list. So this is our list of squares. And I think what we can do here is we can say for let's just say in odd list no, we need a list comprehension. Hold on a sec. So this is a big part of computer programming, is the Google search and the Python list comprehension. I'm skipping past the AI stuff. I hit the button. I didn't even really mean to. Okay. W3 Schools is a great source. The Python documentation itself would be a good source, but okay. Okay. Okay, here we go. This is what we want. This is how we make a new list based on stuff from the old list. Okay. Okay. Um, man, streaming really bogs my computer down. Go back to our code here. So what we can do is we can do square, in times in, for in itself, and make that an entry in this list. So nothing should happen. Okay. And now if I say square list, what's it going to give me? Nothing. If I print, oh wait, hold on, another line. What is happening? It's behaving weirdly. Oh wait. No. Oh. Is it just being better? So these little angle brackets here, those tell you that you're on a line. Exactly means. Boo! Yeah, we're gonna restart the shell, which means we're gonna lose all of this stuff up here. It's not gonna be in the system anymore. But we can just re-enter it. The shell also doesn't want to. Okay, it is full on frozen. Excellent. That happens sometimes in programming, actually. We might. I wish it hadn't, but force this to close. Oof. Okay. Well, I need to go. I need to go get ready for my one student. We'll just do it as a script file rather than try to do it live here. I just want to show you that you could, and you can. Maybe we'll just revisit this. Yeah. This is okay. So I have to. Oh, maybe I don't know. I'm gonna have to figure out what's on there. Let's stop my screen share. I might have to just full on restart my computer to get this to, because this full on crashed. But yeah, I think I'll leave it there for the stream. I'm back. We'll keep doing these. Because I am excited to work on these Euler project problems. It's very satisfying to me. It's a very satisfying type of work. So we'll do that. On Wednesday, if any questions, though, I will probably do an unscheduled stream to answer those questions. But we will definitely be back to finish this up and move on to the next Project Euler question on Wednesday. So join me there. See ya.